Dear students, welcome back to this video. In the last video, we talked about one sample t-test. Now in this video, we are going to continue our discussion on paired sample t-test. So for this video, we are going to use the same questionnaire again. So let's go down. So yes, here we discussed one sample t-test earlier. Now we are going to see what is a paired sample t-test. So what is this test? When is it used and why is it named paired sample t-test? Let's take a look at the definition first. Paired sample t-test is used when you want to compare the mean scores or the average scores for the same group of people on two different occasions. This is the most important part. Compare the mean scores for the same group of people on two different occasions. So we have collected data from the same group of respondents twice. And then we are going to compare those two pieces of information. I know many of you are still confused. Do not worry. Let me give you the example first and then it will be very easy. So let's take a look at the first example. So let's assume there is these two pieces of information that I have. Number one, mean weight of the sample before 3-month exercise versus mean weight of the sample after the 3-month exercise. So remember, in our questionnaire, we collected these two pieces of data. One is the weight before the exercise and one is the weight after the exercise. Now, if you think, in our survey, we had 15 respondents in total. Now, from these 15 respondents, we collected data on their weight before they started exercising. And after the exercise, we went to the same group of people to collect data again on their weight after they're done with their 3-month exercise. So what happened here? We collected data on the weight variable from the same group of people twice. Again, we collected data on the weight variable from the same group of people twice. Now, after we have these two averages, then we can compare whether they're statistically significantly different or the same. Now, my next question is, why are we even comparing this? Why do we want to compare these two means? Because maybe we want to find out that yes, this was the average weight before the 3-month exercise program, and after the 3-month exercise program, we again collect data on the weight of all the respondents. So after comparing these two averages, if we find out that yes, they're different and the average after the 3-month training program is lower, then we can say that yes, after these 3 months, weight on average of the people in my sample has gone down. Please note, through this paired sample t-test, we can find out that yes, whether the means are different or whether weight has gone down. But even if the weight has gone down, we cannot say that exercise was the reason that caused the weight loss. Again, through paired t-test, we can say that yes, the weight has gone down, but we cannot say that 3-month exercise is the reason for this weight loss. There may be many other reasons. Maybe all of them were on a diet, or maybe all of them were ill because of some virus. So the main point that I'm trying to make is paired sample t-test will tell you whether the averages are different, but it will not tell you what is the cause of that difference in these two averages. So please take note of that, because as the definition suggests, paired sample t-test only tells us whether there is any difference between these two average scores. Now let's move on to the next example. Say I have average blood pressure of 20 people before running versus I also have average blood pressure of the same 20 people after running. So again, what I did here, I collected data from 20 people about their blood pressure before running and calculated the average. And then after running, I also again collected the blood pressure data from them and calculated the average. Now after that, I can compare these two averages or these two means using paired sample t-test. Why? Because as per the definition, I have collected data on a variable from the same group of people on two different occasions, one before the running and one after the running. So that's why we have to use paired sample t-test to find out whether there is any statistically significant difference between these two averages. So yes, I guess by now the concept is clear to you. Now that you know the basic concepts of paired sample t-test, let's take a look at the formal boring definition. So here it comes. Yes. So the paired sample t-test, sometimes called the dependent sample t-test, is a statistical procedure used to determine whether the mean difference between two sets of observation is different or not. In a paired sample t-test, each subject or entity is measured twice, resulting in pairs of observations. I know this is really boring, so you don't have to memorize it, but I'm sure you know the concept by now very well. But just take a look at the last wordings here. Each subject or entity is measured twice, resulting in pairs of observation. And that is why this method is called paired sample t-test, because we are collecting data from each person twice. So there is a pair of data or pair of averages for the same person or for each individual. So that is why it's called paired sample t-test again. Now that we know the basic concept, let's take a look at the hypothesis next. What will be the hypothesis for this paired sample t-test? The good news is, for this t-test as well, the null and alternate hypothesis looks exactly the same as it did before in the case of one sample t-test. So the null hypothesis would be there is no statistically significant difference between the two means, and alternate hypothesis would be there is a statistically significant difference between the two means. So it's exactly the same. Why? Because we are measuring the difference between two means again. But here, these two means are collected from the same sample on two different occasions. So alright, without further delay, let's look at the question and move to SPSS and then try to solve a real life problem. So what is the question here? Is there any statistically significant difference between the mean weights of the respondents before and after the 3-month exercise program? Now, as soon as we read the question, we understand that average data on the mean weights is being collected from the respondents twice. Once before the 3-month exercise program, and the second time is after the 3-month exercise program. And as the average data is collected on two different occasions from the same sample, we have to use paired sample t-test in this case. So let's go back to SPSS and try to solve this problem. So yes, we are here in the data view. Now we are going to use paired sample t-test. So let's go to analyze and then compare means, and finally here we will see paired sample t-test. Again, analyze, compare means, and finally we have paired sample t-test. So select this option. As you can see, just as before, on the left hand side we have all the variables listed, and on the right hand side we have a box where we have to bring the variables that we are going to use in this test. Now just as before, for our own convenience, I'm going to come right here and then right click and then display variable names. Now for this question we are going to compare weight, right? So let's go down and you will see that there are two weights, weight before and weight after. So we are going to compare both of these. Now if we take a look at the right hand side, there are also boxes for two variables, variable 1 and variable 2. And if you take a look, it's already mentioned paired here. So SPSS already knows that these two variable measures are in pairs. So they come from the same group of people. So now let's come back here. So let's first select weight before, then select this button. See, as soon as you select weight before, it shifts to the right. Now we have to select the second variable, which is this one. So I select that and then I click on this button. See, it comes under variable 2. So as variable 1 we have weight before, and as variable 2 we have weight after. Now the best part is we are done here. So our input is ready. Now as soon as we select OK, the results will appear. So let's do that. So yes, as I said, the results are ready. Now we can try to analyze our results. Now in the first table, we have two means. In the first column, we have what is your weight before the exercise. So the mean weight for this question is 66. And in the second row, we have what is your weight after the exercise. And the mean weight after the exercise is 57.2667. So we already have these two means, right? Now once we have the value, remember we need another important details from the results. What is that? Yes, we need the p-value. Why? To test whether this result is statistically significant. So we will find this answer to the p-value in the third table. For now, we don't need to look at the second table, so we can ignore this one. So if we come to the third table, here somewhere we have the p-value given. Now, before the p-value, I want to show you something else. Here in the first column, we have something. Let's read it. what is your weight before the exercise minus what is your weight after the exercise. So again, this is weight before minus weight after. So this is basically measuring the difference, right? Again, this here exactly is measuring the difference between two means. Weight before minus weight after. What is the difference? 8.73333. That is the difference. So again, weight before minus weight after is 8.73. That means weight before was higher than weight after. I mean, that's very easy to understand. And if we go back to the first table, we can basically calculate it on our own. So 66 minus 57.2667 is equals to 8.733. So we have the mean difference ready. Now, as I said, we need something else as well. What is that? It's p-value. Now, can you guess where do we have the p-value in this table? Try to find it out within 5 seconds. Yes, you guessed it right. It's at the very end here. Significance two-tailed. This is the p-value here. Now, what is the rule for p-value? If it is less than 5% or 0.05, the result that we get is statistically significant. Otherwise, the result is not statistically significant. So we can very easily see here that this value is very much well below 5%. So that means the difference that we got, it is statistically significant. So yes, from these tables, we have got two important pieces of information. Number one, the difference between the two means, and number two, the p-value. So we know that the difference between the two means is 8.73, and also the weight before the exercise was higher than weight after, and from the p-value we found out that yes, the difference that we got is statistically significant. So we are done here. Let's go back to the Word file again. Let's come back to the question. Is there any statistically significant difference between the mean weights of the respondents before and after the 3 months exercise program? What will be the answer? The answer will be yes. There is a statistically significant difference between these two weights. So we know the answer to this question. Now, what about the hypothesis? We had these two hypotheses, right? So which one do we reject and which one do we accept? Yes, you got it right. We reject the null hypothesis and accept the alternate one. Why? Because the alternate one says that there is a statistically significant difference between the two means. And through our analysis, we find out exactly that yes, there is a statistically significant difference because the p-value is less than 5% in this case. So we are done. That is how we use a paired sample t-test.